This is problem 61 in chapter 20 of Klein's Organic Chemistry textbook, second edition. And here we want to start the synthesis from cyclopentanone, okay? And we want to make these various molecules. And so let's go ahead and get started on these. So for part A, you'll notice that there's a carbon-carbon bond between these two positions. So we need to make an alkene. And then also, it's very key to understand that we have an additional methyl group there, okay? So what you want to think is, how do we make carbon-carbon bonds from ketones? And the answer here is that we would use a Grignard, okay? Methyl magnesium bromide, okay? So when we think backwards from this, you might want to think that this comes from an alcohol. Well, let me back up here. We have this molecule here, and this might come from an alcohol, okay? And that can come from a ketone, okay? And the key step here is the carbon-carbon bond forming step, I would say. And I think we all know from alcohols and alkene chapter how to make an alkene from an alcohol. So let's go ahead and show the synthesis here. What I would do is I would start with cyclopentanone, okay? And I would treat this with methyl in step 1, methyl magnesium bromide. In step 2, I would add some water, and that would give me my alcohol, okay? And then I want to make a more substituted alkene, okay? So the carbon-carbon bond is going to create a tri-substituted alkene, and that's more substituted. And we can just do that with acid and heat, okay, to give you the product. All right, that's the product. Now, in molecule B, we can see that we have, yes, an additional carbon right here. And here we have the Hoffman alkene. Remember, Hoffman elimination gives you the less substituted product. So how do I go from here to an alkene that's between these two carbons? Well, one way to do that is to create a tosylate, so toluene sulfonyl chloride, in pyridine, okay? That will give you the tosylate. This is from, stuff we've learned in the alcohol chapter. And now we can treat this with potassium tert butoxide, for example, and this will give us the corresponding alkene there, okay? Now I'm going to stop the video here because we skipped this, and, well, I told you don't memorize the molecule C until we get to carboxylic acids, and we skip the Baeyer-Villiger oxidation. So A and B are very relevant for this upcoming